This is a physics video on classical mechanics. It's based on Newton's second law. So let's get to the question. We're given block P of mass 2 kilograms. It's said to be connected to a block Q of mass 3 kilograms that is connected by a light inextensible string. Those two blocks are connected by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. So that's the angle there. And block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees. This block is pulled at an angle. It's not along the horizontal. That angle makes 25 degrees with the horizontal, so make note of that. And it's also said that block P moves on a rough section AB. So AB, in this case, I'm going to draw it for you. This is region AB. So this patch here, we are told that it's rough. And then this patch here, from B to C, it's frictionless. This one has friction, this one is frictionless. Okay, let's continue reading the question. So block P moves on a rough section AB of the incline, while block Q moves on a frictionless section BC. That's BC of the incline. Okay, the first question is usually asking us to state Newton's second law. I'm not going to write it down, I'm just going to state it in words, and hopefully you have a book note next to you that you can actually use to write down the definition. So Newton's second law states that when a force of F net is applied to an object of mass m, the object of mass m will accelerate in the direction of the net force. The acceleration of the object of mass m is directly proportional to the force F net that's applied to it and inversely proportional to the mass of the object. So the relationship in simple terms can be written this way. So F net is directly proportional to A. Okay, let me do this. Make it more accurate. Let me write it this way. So the acceleration is directly proportional to F net and inversely proportional to the mass. So if you have, in other words, it's the same thing essentially. Directly proportional to the inverse of mass is the same as inversely proportional to mass. So yeah. Now let's go to the second question. The second question would be, I think I'll have to write it down so that we keep track of what we're doing and what exactly is needed. So the next question says we should calculate the magnitude of acceleration of block P. So we want A, the acceleration of block P. We have to calculate the acceleration of block P while block P is moving on section AB. So we want the acceleration while block P is moving on this section, this friction, this section with friction. Okay, when you do these questions, it's important to first write down Newton's second law because we use it to answer the questions. And because the blocks, this block is moving, or the two blocks, the block system is moving upwards along the incline, we only consider forces that are horizontal in relation to the incline or parallel to the incline. That's the right way to say it. Yeah. So we consider forces that are set along the incline. So I think we should first draw a free body diagram for block P that will make it more convenient. It's going to be convenient for us when it comes to doing the actual question. So this is the incline, this is block P. The forces acting on block P are the normal force due to the surface, the perpendicular component of weight, the weight, and here this is the parallel component of weight, but then we're going to write it here to make things easy. W parallel, and there is also friction. The vector magnitude is not to scale. I wanted to point that out. I'm just drawing it to represent everything clearly. So just because this one is longer than others, it doesn't mean it's the biggest. And yeah, it could be the biggest, but then it's not something I'm interested in knowing now. Okay, so here there's also this one, tension. Tension is going upwards. We're going to choose the direction upwards along the incline as positive. So make note of that. And then here on FNet, we're going to put all the forces that are acting on this object in this fashion. So we have tension. So the resultant force is a sum of individual forces. So it's going to be plus at first. So we're going to have tension. We're going to have W parallel. We're going to have friction. And that's all going to be equal to MA. Then this is W. We know that W parallel is equal to W sine theta, this angle here. And remember, this was 30 degrees, and therefore this angle is also 30 degrees. This is W sine theta. This theta here is 30 degrees. Let me just write 30 degrees already. 30 degrees. And then we also have friction. Friction was given. Was it given? Let's check. Oh, friction is actually given here. NP friction is 2.5 newtons on P as it moves. So friction is also given 2.5 newtons. Okay. So now when we substitute the values here, it's important to make sure that we substitute them with the correct signs. For example, T is going upwards. It's going to be positive. The component of weight is going downwards along the slope, so it's going to be negative. That's going to be negative. And remember, here we're going to put this, but we also know that this is equal to W, weight is mg, and mg is mass times by the gravitational constant. The mass of P is 2 kilograms times by 9.8, which is the gravitational constant, and that's going to give us 19.6. So this is going to be 19.6, and then we're going to write sine 30 degrees. Sine 30 degrees. As a result, W perpendicular, or the perpendicular, W parallel is going to be equal to 19.6 sine 30 degrees. So we're going to put that here. 19.6 sine 30 degrees. It's negative because it's going downwards, and then the force friction as well is going to be negative because it's going downwards, and that's going to be equal to this mass and times by the acceleration. The object of interest here is 2 times by the acceleration a. As a result, we will have something like this, and then we're gonna add, we're gonna subtract, we're gonna do this calculation here. So that's 19.6 sine 30 degrees minus 2.5. That's going to be equal to minus 12.3. So we have minus 12.3, and that's going to be equal to 2a. We're going to call this equation 1 because you can see that it's not going to be possible for us to find acceleration at this point because there's also another unknown, tension. So to find this leads us to a very predictable direction, which is simultaneous equation. So now we're going to have to use the other block, the 3 kilogram block, to find its own equation in that way that will then help us find T, and then we're going to use T to find A. So now I hope you've written all of this. You can pause the video, write all of this, and continue again because I'm going to remove everything here, and the only thing that's going to remain is this equation because it's very important. Okay, let me remove everything, clear some space. Let me rewrite that equation on top. It's t minus 12.5 is equal to, that's 12.3, that's not 12.5, that's equation 1. It's 12.t minus 12.3. Okay, now I'm gonna use the same f is equal to ma. Now I'm gonna be using it for the block Q. For block Q, so on Q we have, let me draw a free body diagram for Q. This was for P, this one is gonna be for Q. On Q we have tension, there is no friction. We have W perpendicular, we have weight, we also have W parallel, this is tension, and then because this force is acting at an angle here, this force at an angle of 25 degrees with the horizontal, we can resolve these into the x and the y component to make things easy. This is going to be f a x, this is going to be f y x. We know that the angle is 25 degrees, so keep that in mind. And we also know that there is a normal force which is perpendicular to W perpendicular, like it's opposite W perpendicular, but then the drawings here not easy to make. So if you look at Q, the forces acting on Q are FAX plus W perpendicular plus T is equal to MA. Here we know that FAX is equal to, because this is adjacent, it's going to be equal to FA cosine of 25 degrees because of that angle there. So this is going to be FA cosine of 25 degrees. And then W parallel is going downwards with tension, so it's going to be negative. And we know that this is equal to W sine 30 degrees minus, because tension is going down as well. We don't know what tension is. And then the block is 3 kilograms, so that's 3A. At the end of the day, FA is equal to 40. So this is 40 cos 25 degrees minus weight. The weight of that block is mg. 3 times 9.8 is equal to 3 times 9.8 is equal to 29.4. 29.4. So this is 29.4 sine 30 degrees minus t is equal to 3a. Let's call this equation 2. This is equation 2. So now what we're going to do is we're going to add this equation and that equation. When we add them, t and t is going to cancel. This, when added to that, will give an answer. Wait, I have to write it down. Oh, that's gonna give 9.25, and 2a plus 3a is gonna give 5a, and therefore we divide by 5 on both sides. A is gonna be equal to 1.85 meters per second squared. I'm gonna continue with other questions on the next video. I'm just gonna leave the link below it. Thank you.